Hi there, and welcome to this lesson. In this lesson, we'll be learning about presentation of statistical data. And under presentation of statistical data, we'll be learning about grouped frequency tables. Okay, so in the last lesson, we did frequency tables. In this lesson, we're doing grouped frequency tables. Now, as the lesson progresses, if you come across anything you don't understand, be sure to contact your tutor, who would be more than happy to help. And yeah, let's jump right into the lesson. So, presentation of statistical data, grouped frequency tables. So, grouped frequency tables. Now, what exactly are these about? Now, when statistical data contains a large number of distinct values, it becomes difficult to represent it on a regular frequency table. Okay? Now, in such cases, we make use of grouped frequency tables. Now, the key phrase here, large number of distinct values. And I have this example here, and it says the data set below contains the wages of 50 workers in a factory. Okay, and we've been asked to construct a grouped frequency table to show the distribution. So we have this here, the wages of 50 workers in the factory. We have someone on 82, 132, 199, and basically something you note about, I don't think we don't even have a single value that occurs twice. Okay, we actually have, so basically if you were plotting a regular frequency table, you pretty much have every single one of these values, occurring once. Okay, and basically here is our group frequency table. Okay, and basically we start with class intervals. Okay, now when we group data, we call our groups class intervals, and then we have tally and frequency as usual. So what we're going to do is we're going to draw a frequency table, but then we're going to group our data. Okay, and here's how we do it. We start off with the first group, and this group is for numbers between 0 and 99. Like I said, we call them class intervals. So this class interval is 0 to 99. So any number that's between 0 and 99 would fall in this class interval. And then we have 100 to 199. So any number between 100 to 199, for example, we have 132 up there, would fall in this class interval. And then basically we have 200 to 299, 300 to 399, 400 to 499. And these 5 class intervals would be enough to cover our data, basically. So as opposed to having 50 values, okay, and then frequency would just say 111 for each of them. We actually group them into 5. All right, and just from this point on, we just follow the regular system. We're going to work our tallies now, and we start off to cross out 82. Now 82 falls between 0 and 99, so we bring the tally here. Do the same for 132. 132 will go in the second class interval, so we put a tally, and we just keep doing that till we get to the end and we have all our tally marks in place. And then we just go ahead and read the frequency. The first one we have 5. The second one we have 3 sets of 5 with 1, that's 16. And then 3 sets of 5 with 4, that's 19. And then we have 5 with 1, 6. And then we have 4 in the end. And that's it. That is how you plot, or that's how you construct a grouped frequency table. Okay, so now there are some very important properties of grouped frequency tables that we need to discuss. Okay, and we'll just start off with the first. The first one is class limits. Okay, so very important properties, class limits. And class limits basically for a given class interval. Okay, so just take any one of those class intervals there. The class limits are the n numbers of a given class interval. Okay, so the n numbers, or the numbers on the two ends. For example, if you have for the 0 to 99 class interval, 0 and 99 are the class limits. Okay, so the number, the two, basically just the two numbers, it goes from 0 to 99. The two class limits are 0 and 99. And basically 0 is the lower class limit and 99 is the upper class limit. Very simple. Okay, so the class limit, that tells you from where to where. All right, very simple. Now What about class boundaries? Now, class boundaries actually very, very interesting. Okay, we use this particularly when we're constructing histograms. We'll learn about those later. But one thing I need to think about, okay, I need to think about a border. All right, think about a border. And basically, the boundary is a borderline, okay, between two classes. It's the borderline, all right? And then I'll tell you that if the class intervals are recorded to the nearest unit, the class boundaries are plus or minus 0.5. Okay, now here's what this is. The class boundary you have, let's look at the first two class intervals here. We have 0 to 99 and 100 to 199. Now we have two classes and we have a boundary between them. The boundary comes between 99 and 100. Okay, are you following me? The boundary comes between 99 and 100, okay? And basically between 99 and 100, we have 99.5, okay? It's the borderline that divides the two classes, okay? And basically we have a lower class boundary. We also have an upper class boundary. So basically, the class boundaries of, for example, the class boundaries of the class 0 to 99 are minus 0.5 and 99.5. Okay, so here's what to do. The class boundary, you subtract 0.5 from the lower limit, okay, and then you add 0.5 to the upper limit, okay, and this gives you class boundary. Now you basically class boundary for the first class, the lower class boundary not relevant, okay, but then for example if you're doing the second class, the class boundaries for 100 to 199 will now be 99.5 to 199.5. Now, if you notice, the upper class boundary of your first class is the same as the lower class boundary of your of your second class. So basically, it is the borderline between the first class and the second class. And similarly, if we're doing the class boundaries for the third class there, you'd have 199.5 and 299.5. Okay, so now class width. Okay, this is actually very simple. It's basically the gap. Okay, the gap between two boundaries. So you have for a given class interval, the class width is the difference between the lower and upper boundaries. So basically, you have two borders, and the class width is simply the gap. The gap between the two borders, okay, and basically the class width for the 100 to 199 class interval is 199.5, which is your upper class boundary, and then which is your upper boundary, and then your and then 90 minus 99.5, which is your lower class boundary, and basically it gives you 100. And usually the class width is the same as working the same thing on the class limits. Okay, so you can do it on the class boundaries, you can do it on the class limits, but then best way to describe it, it's the gap between two boundaries. So it is this difference between the two boundaries. Okay, so think of it in that manner. And then finally we have the class mid value. Okay, the class mid value. The class mid value is pretty much self-explanatory. It's the middle of each class, a number in the middle. And basically for a given class interval, the class mid value is the midpoint of the class interval, and it is half the sum of the upper and lower class limits. For example, you have for the first class there, you have 0 to 99. What you do is you add 0 and 99 together and you divide your result by 2. For your second class, you have 100 to 199. You add 100 to 199 and you divide by 2. So let's go over all of them again. We have class limits, just the n numbers of the two classes. So the class limits of 0 to 99 is 0 and 99, with 0 being the lower class limit and 99 being the upper class limit. And then we talked about class boundaries. Class boundaries serve as the borderline between two classes, okay, and usually you will find the class boundaries at the point between where the first class stops and where the second class begins. Okay, and basically what we do is if the class interval is recorded to the nearest unit, then the class boundaries are plus or minus 0.5. Now I need to explain that. Now basically if you had for example, if you were counting in tens, okay, and that was 0 to 90, and then 100 to 99, 100 to 190. Basically, if your numbers were occurring in tens as opposed to units, then you would have the number between 90 and 100 would be 5. Okay, so if you're counting your numbers in tens, you would have plus or minus 5. But very often, for pretty much any data you're usually working with units, okay? And basically counting the numbers 1, 2, 3, 4, 5, 6. And basically the class boundary, difference between the class boundary is always 0.5, okay? So 0.5, and then class boundaries of the 0 to 99 class intervals will be 0 minus 0.5, which gives you minus 0.5, and then 99 plus 0.5, which give you 99 plus 5, 99.5. And then we have the class width, just simply the gap between the two boundaries for a class interval. And a class mid value, you sum the two values together and divide by 2. And to find the mid value, you work with the limits, not the boundaries. If you work with the boundaries, you most likely, or would you? Oh, no, 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 you probably wouldn't. Okay, but then basically it's the class limits you work with. You work with the class limits, you add them together, and then you divide by 2. Now, let's go ahead and solve some examples. Example 1. Okay, this looks interesting. So we have the masses of 40 students were recorded to the next kilogram, okay, to the nearest kilogram, and the results are shown in the data set below. Construct a grouped frequency table to show the distribution, taking equal class intervals 57 to 61, 62 to 66, and so on. And then we've been asked to then identify the model class. So the model class is the class with the highest frequency, very simple. And then we've been asked what are the mid values of the third and fourth class intervals, what are the class boundaries of the class intervals. Okay, so let's get right into it. So the first thing we've been asked to do is construct a grouped frequency table to show the distribution. So we have our information there, our data set, we have our table, okay, and basically what we're going to do now is we're going to then work our tally system. So we'll cross out 60. 60 is between 57 and 61, so put a dash there. 64 is between 62 and 66, so put that there, and then we keep doing that up until 73, and we'll end up with that. Okay, and then we just work out the frequencies. We have the first one 11, the second 16, then 9, and finally 4. Simple, straightforward. Now, the next thing we've been asked to do, we're asked to identify the model class. So the model class is the class interval with the highest frequency, and in this case we have the 62 to 66 class interval is our model class with a frequency of 16. That's the highest frequency. And then we're asked to find the mid-values of the third and fourth class intervals. So for the third, the class interval, we have 67 to 71. Again, the mid-value is 67 plus 71 divided by 2. And if you work that out, you would end up with 69. And then for the fourth class interval, we have 72 to 76. We have 72 plus 76 divided by 2, give you 74. And very simple. That's pretty much it. And then let's do the final one. Basically, we've been asked to find the class boundaries. So our digits here, our numbers are unit numbers, okay? So basically, we'll be working our class boundaries with plus or minus 0.5. So we have 57 to 61. We subtract 0.5 from 57, and then we add 0.5 to 61. Just that easy, okay? So we start off 57 minus 0.5 is 56.5. 61 plus 0.5 is 61.5. I do the same. 62 minus 0.5 is 61.5. 66 plus 0.5 is 66.5. Okay, I keep doing that. I get to the end, and if you look closely, you'd find that the upper boundary of one class is always equal to the lower boundary of the second one. Okay, so we have 61.5 from the first to the second, we have 66.5 from the second to the third, and basically 71.5 from the third to the fourth. So you can see these are the border lines between each of the classes. And that would bring us to the end of this very simple lesson. Okay, you can go ahead now and attempt questions from the worksheet. Bye for now.